Homework number 22. Question number 1 asks you which number is equivalent to 3 to the 6th divided by 3 to the 2nd. Whenever we have like bases that have exponents, we know that the shortcut is to keep the base the same and subtract the exponents. So starting from the numerator, we're going to subtract 6 minus 2. When we keep the base the same, our new exponent will be 4. So 3 to the 4th is equivalent. That could be an answer. And so could the actual value for 3 to the 4th power, which is 81. For question number 2, we're multiplying like bases, which is a different shortcut rule. You still keep the base the same, but when you're multiplying, you get bigger. So we're going to add these two powers together. 3 plus negative 7. When we keep the base the same, our new exponent will be negative 4. This is a correct answer, but it's not one of the choices. 15 to the negative 4th power is not the same as a base of negative 15. Whenever you have a negative power, that means that your base is in the wrong location. So instead of 15 being its own whole number, we're going to put it down here in the denominator. Once we do that, the exponent becomes positive because now it is in the correct location. We're going to fill the numerator with a placeholder 1, and now we can find our answer. Question number 3 asks us to say if Maria is correct in stating that this relation is a function. A function has no repeating x values with different y values, right? Every input, 2, 3, 5, can only have one output. So we can't repeat any x values with different y values, and there are no repeats here. So we're going to explain that yes, Maria is correct, and then we're going to state the rule for how something is a function, and we can use this for every question. Maria is correct because every input can only have one output. That's the answer for every question. Whether the answer is yes or no, this statement will always work. Every input can only have one output. So she's correct. Question number 4 asks us to write the new coordinates after a reflection over the y-axis. When we do that, our a becomes a prime, and when you reflect over y, you change the x value. So that's going to be negative 2, negative 1. For question 5, it asks us to translate 3 units up, which adds 3 to y values, and 4 units left, which subtracts 4 from x values. So b prime will be negative 10, positive 10. Question number 3 asks us to rotate 270 degrees clockwise. If you were to turn 270 degrees, that would be 3 90-degree turns. It's also the same as one 90-degree turn counterclockwise. So since we don't have a rule for 270, we're going to use the 90-degree rule for the other direction, counterclockwise. And when we do that, we swap the placement of the numbers, so negative 5 will be first and 4 will be second, and then we draw the arrow to change the sign of the first number. The arrow is drawn in the counterclockwise direction, which is direction we were told. The last one asks us to dilate by a factor of 1/2, which means we're going to multiply each coordinate by 1/2, making d prime negative 5, 4. Question 8 is another question about functions. Which one of the functions listed below is correct? Well, actually, these are all relations. We're going to decide which one is the function. And we're going to do that by looking at the x values. If you have a repeat, you're not a function. And this one, every input has only one output. Number 9 asks us to simplify each of these expressions, making sure when we're done that all of our exponents are positive. So when we multiply like bases, we keep the base the same, and we add the exponents together. The final answer is r to the 6th. For number 10, when we divide like bases, we keep the base the same and we subtract the exponents. The final answer is 5 to the 8th. Now this one, there's nothing to do. There's no shortcut here because we're not multiplying or dividing. So we're simply going to make this power positive by stating where it should be, right? A negative power means you're in the wrong location. So we're going to flip it over and make the power positive. For number 12, we're dividing like bases, so we're going to keep the base the same, and we're going to subtract the powers. Now watch. Subtraction is a shortcut, but the denominator also has its own negative sign. And when you have two minuses in a row, you then have a plus. So a to the 8th. Number 13 asks us if Juan made a mistake, right? A to the 2nd times a to the 6th, Juan said is a to the 12th. But the rule is a to the 8th. And that's because when you multiply like bases, which is what this is, when you multiply like bases, you add the exponents. That's all you have to write. You just have to write the rule and what it is applied to. It is applied to multiplying like bases. You add the exponents. Question number 14 asks you to solve for x. So you might need a calculator for this part. 2.5 times 5, right? You pick your calculator up. 2.5 times 5, we get 12.5. On the other side, there's no math to do, so I'm just going to rewrite it. Now I'm going to try and get my x's on the same side, so I think I'm going to subtract 7.5x because I like my x's on the left. So over here, I'm going to get negative 5x plus 12.5 equals negative 0.5. This time I'm going to subtract 12.5 from both sides. And now I'm going to divide by my coefficient, which is negative 5. So I'm going to divide negative 13 by negative 5, and I get a pretty good looking decimal. So you could write it as a decimal since it truncates, 2.6, or you could leave it as a fraction, 13/5. But don't forget your answer is positive. For question number 15, we're going to distribute negative 1/3 times 6, which is negative 1 times 6, and then divided by 3, giving us negative 2y. Negative 1/3 times 6 again will give us just a negative 2. And we're going to rewrite the rest of the question. On the left-hand side here, we have like terms, so we're not going to use an inverse operation. We are simply going to compute negative 2 plus 21, which is going to give us 19. And then I need to get my y's on the same side, so I'm going to add 2y to the both sides using my inverse property of equality here, rewriting as 19 is equal to 5y, dividing by my coefficient, and leaving my answer this time in fraction form. You do not have to convert it to a decimal. Questions 16 and 17 ask you to transform the triangle shown below. For question 16, we're going to rotate 90 degrees clockwise. So first, I need to know what my original points are, A, B, and C. Because a rotation requires you to do some math with these points. A is 0, negative 1, B is negative 1, negative 4, and C is negative 3, negative 2. When I rotate clockwise, 90 degrees, I swap the x and y coordinates, and then I change the sign going clockwise. Now the good news is 0 doesn't need to change signs, so that one doesn't really matter. But for B, we're going to swap the order of the points and then change the sign of the y coordinate. Again, C, we're going to swap the order of the points, keeping everybody the same, and then we change the sign of the y coordinate. So my new shape will be negative 1, 0, that will be A prime, negative 4, 1, that will be B prime, and negative 2, 3, that will be C prime. And now I can now I can connect these points to draw a triangle A prime, B prime, C prime. Question 17 asks us to reflect triangle ABC about the x-axis. So that's this axis here. So we're going to flip over this axis. Now we can do it by counting boxes. So down 3 is where it's located now. So up 3 is where it will be located next. So we could certainly do that by counting boxes and calling it A prime. Another thing we could do is we could write the original coordinate points, and when you reflect over the x-axis, you change the y. So B prime would be 0, positive 5. Same thing for C. The original C was -4, -5, but when we reflect over the x-axis, we change the sign of y, giving us -4, positive 5. So there's our new triangle labeled A prime, B prime, C prime. The question below asks us here, describe in words the effect a reflection over the x-axis has on a triangle ABC. What parts are congruent to the new triangle A prime, B prime, C prime? So the effect is that it is a rigid motion. A reflection is a rigid motion. So all sides and all angles are congruent. Another way that sometimes it's written is that angle A is congruent to angle A prime, right? Angle B is congruent to angle B prime, and angle C is congruent to angle C prime. You got that little congruent symbol there. And sometimes they do it with sides as well. Side AB is congruent to A prime, B prime. That's another way you can write it. Side BC is congruent to side B prime, C prime, and side CA is congruent to C prime, A prime. The end.